Okay, morning everybody. Okay, welcome to the last segment of your sound topics. Okay, this segment revolve around two main components, which is primarily what we know as the pitch and the loudness of the sound. Okay, we will look at it in detail. Same thing before I continue, make sure you have already gone through the two aspects, the two video that is early on, the 13.1 sound, 13.2 and 13.3 transmission of sound and reflection. Okay, once you have done that, okay, make sure you uh, take on the right mindset to look at 13.3, okay, to get a rough idea of what is happening to on pitches and sound, what are the important keywords and important concept that we are dealing with. Okay, pitch and loudness. Okay, pitch in general, okay, is what we commonly know as high pitch and low pitch. And but in physics, we take we look at what actually control pitches. Okay, for pitches is actually primarily depending on the frequency of the sound. Okay, like we say, the higher the frequency, the higher is the pitch. And how do we define frequency? In chapter 11, we look at transverse wave. When you look at waves in general, frequency is defined as the number of waves in 1 second. Okay, and we have a unit we know as hertz, Hz. Okay, oh, this should be small one, small z. Okay, so in general, frequency talk about 1 second, how much wave, how many wave has passes this point in 1 second, and that number will actually give us the frequency of the sound itself. And we talk about frequency, it can be any number. It range from 10, 20, 30, right up to 1,000, 10,000, 30,000. So if you look at the pitches, how do we look at pitch? It will be the lower the pitch, and the lower the frequency, the lower the pitch, higher the frequency, higher the pitch. In terms of representations, okay, other than number, we can actually represent frequency in terms of graphical. So we look at, let's say, number of cycle here. So in 1 second, let's say example, in 1 second, I have 10 cycle. I have 10 wave passing through, which means I will say that one cycle, okay, of wave will actually takes 0.1 second. Okay. In this case, what we're looking at for is, if you look at in terms of frequency, 1 second, 10 cycle, this is what we call 10 hertz. In terms of graph, when you look at 10 hertz, it's quite hard to see from the graph itself. Okay, but what we can see is we can actually see the period, the time taken for one cycle. So for example, for one cycle, it will be ranges from crest to crest or the start to start point. So this would be 0.1 second. Okay, this will be 0.1 second. Now, if you look at another wave, let's say we look at 1000 hertz here. Okay, 1000 hertz, what do we mean by it will be in 1 second, or 1100 or 1000 hertz, 1000 wave, 1000 cycle passes through a point in 1 second. This is what we mean by frequency. But in terms of graph, it's quite hard to see. So we look at the period. So let's say for one cycle, how long does it take? Okay, for one cycle, how long it take? It will take 0.001. Okay, so it's 0.001, 0.001 second. So it will be a shorter interval here. So this is what we call a period. So which means that for the wave here, this period here will be zero. So give me a minute. So which means for the wave itself, okay, in 1 second, I will actually take only 0.01 cycle only. Second, 0.001 second. Okay, so this is what we mean by in one cycle. Okay, so you will find that in terms of frequency, if you look at the number itself, this is high pitch, this is low pitch. In terms of representation of the graph, you'll find a high pitch wave is actually represented by wave whereby they are more compressed together. They are like pushed towards each other. So the shorter the wave, the shorter the frequency, the shorter the period, the higher the frequency. So this is what we mean by low frequency and low pitch and high pitch. Okay, the formula, there is a formula here, but we don't need to rely on formula just based on common sense. Okay, so you find that high pitch wave, other than having a large frequency, if you look at the graphical presentation, it will be actually more compact. Okay, each wave is actually nearer to each other. If you look at low pitch, sound, you'll find that the wave are actually more spaced out. Okay, the cycle, the time, the period, the timing for one cycle is actually larger. Okay, and one thing to take note when you look at frequency, one of the famous number that we need to take note is what is the audible frequency for human. Meaning human beings from young babies, adults, all these things, we are able to hear a certain range of frequency. The frequency compared human to maybe dogs, animals, bat, or even dolphin. Okay, the range of frequencies lapses or it changes. For human being, it will be 20 to 20,000 hertz. For dolphin, it will be higher. Like even, like say, example, for mice, for rats, okay, they can easily hear frequency up to 70,000 hertz. Or for dolphin, it can be as high as 80 or 90 hertz itself. And on the other hand, if you look at elephants they communicate using low frequency, 10, less than 10 hertz, or sometimes maybe it's like around 20, 35 hertz. That's their range of communications. Okay, so that's what we mean by different type of frequency range. And one of the range that you need to take note is audible frequency for human being. Loudness refers to the amplitude. Okay, loudness, how loud, whether it's a softer sound or louder sound. In physics, loudness actually depends on the amplitude. And where is amplitude? Always remember, amplitude is actually from the rest point to the maximum displacement. So this is considered as amplitude. This is considered as amplitude. So in a nutshell, you'll find that the louder the sound, it will correspond with louder, bigger amplitude. Softer the sound, it will be a smaller amplitude. So you look at amplitude between the rest position to the maximum, you'll find that the amplitude is actually different. The smaller it is, the softer is the sound. The louder it is, the bigger it is, the louder is the sound itself. Okay, and this is what we mean by loudness. So if you put everything together for a sound itself, there are actually various factors, and the two factors that involve sound that we cover here is what we call your pitch and loudness. So for a sound, you can actually increase the loudness, which means I increase the amplitude, or I can decrease the amplitude here. Okay, or I can decrease the amplitude here. Okay, or I can actually generate a high pitch noise or higher pitch noise or even a slower pitch noise. Okay, higher pitch, remember, the time between the wave is actually shorter. So high pitch, the time between one cycle is smaller. Low pitch, the time between the wave on one cycle is actually bigger. Okay, so this is what I mean by low pitch and high pitch. Okay, and these are two aspects between sound. In a nutshell, pitch and loudness, there are two different aspects. Okay, they are controlled by two different factors. They can be represented in a graph differently. Okay, and so this is where we end off in our last section of sound, pitch and loudness. Okay, so the last segment, 13.4, you look at the pitches, you look at pitch, and you look at the loudness. Okay, controlled by the various factor, which is frequency and amplitude itself. Okay, so this will be the end of this particular video. Okay, so if you have other topics that you're having problem, okay, remember, refer back to my YouTube channel for various topics that you are of interest. Okay, anything, just leave your feedback in the comment bar below. Okay, and remember to subscribe to the channel to get some latest update of new topics or new videos. Okay, the subscribe button below. Okay, just click it. Okay, if any questions, you can leave it in the comments bar at the bottom there. Okay, thank you.